Hi, welcome. This is Corey Glodek, CSC 480, Assignment 4, K Nearest Neighbors, and the Extra Credit Joke Recommender. As before, I restarted the kernel and cleared the output. We'll start by importing pandas and numpy. And then all the methods. The first one is the process data. For the movie data frame, when we import it, it does need to be cleaned a tiny bit more, get rid of all the kind of junk, fill all the nans with zeros, rename the columns for users, and then set that to the index. There is one row that has no values whatsoever, so we ended up dropping that one, and we returned the data frame. All right, Pearson calculation. Initialize the variables. We're primarily looking at the values in each row for the target X and user that are not NaN, basically for what's overlapping between the two. We'll tally both of them individually, grab the mean for each, and then we'll apply the Pearson equation for that, and returning it all. Finding K nearest neighbors. Grab that. We're going to replace all the zeros with nans now so that it's easy to identify which one's which. We're going to add a Pearson correlation column all the way at the end. And for the range, for all the rows, with the exclusion of the test size, then we're going to make the Pearson call for the test user and that individual target X, which is I. And then we'll add that to the end of the Pearson. Then we're going to sort all of those so that they're largest to smallest. Predict rating. Our movie target, our K value, our data frame. We're going to iterate through the K nearest neighbors and calculate the predicted rating. If it's not NaN, then we predict, get the similarity rating. Sometimes the similarity is 0, in which case we're just going to go through the first 20 and average those. Then if it's not 0, then we do this calculation. Get recommendations. We make the initial call for find K nearest. Username, we want to identify that and have that as a pointer. If it's less than, if it's within K, then we're going to increase the range of the K nearest neighbors. For each one that is empty for the user, then we're going to make the call predict rating and identify what that is. And then we're going to sort those based on largest to smallest, and then we'll print them out. This is the mean absolute error. We go through that, iterate based on the shape, if it's not empty, and then we predict the ratings and subtract that from the real. And then if it's 0, then we just add 0 because it is 0, and then return those. So let's movies, process the data. Let's grab the mean absolute error for the test users using K3. We've got 9.95. Let's predict the movies for NU1 and the ratings, NU2. And let's do 5 and 19 just for giggles. Holds flat, runny Babbitt, which I hope is a bad bearing joke. Extra credit. We needed to modify it, just take the last 100, and then we mix them up and we use the last 20 as the test set. K equals 47 seemed to be the best. And we'll run that for the mean absolute error. That seems to take a little bit, so we'll just test these. Well, I guess after this runs. There we go. And now for user 96, we have a bunch of these. It does catch some users do not have any jokes that weren't rated, so it just kind of catches it and lets you know. That's K nearest neighbors for assignment 4. Thank you very much. Have a great day.